So far we've thought of profit maximization as a one-step process where we choose the production plan by finding a tangency between an isoprofit line and the production frontier. It turns out that we can also think of profit maximization in two steps. In the first step, we think about how to produce different levels of output in the least costly way possible. And then in the second step, we ask how much should we produce in order to maximize the difference between cost and revenue. We'll start developing this idea here by deriving cost curves in a way that's analogous to how we've derived marginal product and marginal revenue product curves before. We begin with the usually shaped production frontier that starts shallow, becomes steeper, but eventually again becomes shallower. We'll denote as production plan A that point on the production frontier where the switch happens. The switch from the production frontier becoming steeper and steeper to the production frontier becoming shallower and shallower. The slope of the production frontier, in turn, is equal to the marginal product of labor. So we can denote the slope at production plan A as the marginal product of labor at A. Since the marginal product of labor is equal to the slope of the production frontier, it starts out small, becomes larger, and eventually declines again. Furthermore, since we defined production plan A as that plan on the production frontier at which the slope switches from getting steeper and steeper to getting shallower and shallower, the marginal product must attain its highest value at production plan A. The marginal revenue product curve is then the same as the marginal product curve, except it's scaled up or down depending on whether price is larger or smaller than 1. If price is equal to 1, then marginal revenue product is equal to marginal product, as illustrated here. So far we've just reviewed what we've done in previous graphs, but now we start with something new in panel D. We begin by inverting panel A, flipping the axes so that labor now appears on the vertical axis and output on the horizontal axis. This gives us what we can call an inverse production frontier. It's a production frontier that tells us for different output levels on the horizontal axis how much labor will be required. It has the same information as panel A, just presents the information in a different way. In panel A, the fact that it's initially getting easier and easier to produce is represented by the fact that the slope of the production frontier initially gets steeper and steeper. In panel D, the same idea is represented by the slope of the inverse production frontier initially getting shallower and shallower. Initially, as we want to produce more, the increase in labor that's required is less and less. Thus, shallow slopes in panel A become steep slopes in panel D, and steep slopes in panel A become shallow slopes in panel D. In panel E, we simply multiply labor by the price of labor, or the wage. Thus, we get what we can call a total cost curve. This curve tells us, for any level of output, how much it will cost us to hire the labor that's necessary to produce that level of output. In essence, all we've done is we've converted the units on the vertical axis from labor hours to dollars by multiplying the axis by the wage. The slope of this cost curve is then what we call the marginal cost. It tells us the additional cost that will incur if we decide to produce one additional unit of output. Since the slope is initially steep and becomes shallower and shallower, we know that the marginal cost of producing additional units of output initially falls. This is because initially it gets easier and easier to produce as we begin production. Eventually the cost curve becomes steeper and steeper, indicating that the marginal cost of producing more increases. This is because eventually it becomes harder and harder to produce more because of the shape of the underlying production frontier. At point B, for instance, the slope might be 20. That tells us that when we're currently producing 10 units of output, it's costing us $300 to do so. And if we want to produce one more unit of output, an 11th unit, it'll cost us $20 more. Since the slope of the cost curve becomes shallower until we get to point A prime and then becomes steeper, it must be that the marginal cost starts out high, becomes smaller until we get to point A prime, and then increases, as depicted in panel F. In going from panel E to panel F, we're doing in essence exactly the same as what we did in going from panel A to panel B. We're going from a panel where slopes indicate marginal quantities, marginal product in panel A, marginal cost in panel E, and then illustrate those marginal quantities on the lower graphs. All of the shapes of the various curves in panels B through F arise because of the shape that we've assumed for the underlying production frontier. That production frontier indicates that initially it gets easier and easier to produce and eventually it gets harder and harder to produce. That's what causes the inverse U shape for the marginal product and marginal revenue product curves. It's what causes the inverse production frontier shape that initially starts steep, becomes shallow, and eventually becomes steeper. And that in turn causes the U shape for the marginal cost curve in panel F. What does any of this have to do with profit maximization? Well, we said that we can think of profit maximization as a two-step process, where in the first step we think about cost. How do we think about cost here? We ask in panel D, what's the least amount of labor required to produce each level of output on the horizontal axis? We then multiply that amount of labor by the wage to get the answer to the question, what's the least cost necessary to get to different levels of output on the horizontal axis in panel E? And from that, we can derive the marginal cost curve that tells us the additional cost we incur from producing additional units of output, assuming that we produce output at the lowest cost possible. What we've done here, in essence, is the first part of profit maximization. We've minimized the cost necessary to achieve different levels of outputs, and that is represented in the cost curves that we've derived.